So today we are going to be looking at patterns, picture patterns, and we're going to write an equation for the pattern. Now specifically, these patterns are all going to be quadratics. All right, so what we're going to have to do is write an explicit equation for how many squares there are in the pattern for, let's say, figure X. All right, so I like to break down this process into 3 steps. Okay, so step 1 is to figure out what the pattern is and describe it in words. Okay, and when I say figure out and describe it, I mean just generally. Like if I look at this first pattern here, notice I've got a rectangle, and then I've got a bigger rectangle, and then I got a bigger rectangle. So clearly the pattern is the rectangle is just getting bigger. Both the width and the length are getting bigger. So if I try to generalize it for figure X, I know I'm just going to have an even wider and longer rectangle here, assuming that figure X is bigger than figure 3. Okay, so that's step 1, is to kind of generalize and put into words what the pattern is. Step 2 is to kind of give some numbers to that description. And when I say kind of give some numbers, I mean actually count things out. For example, I know the length of this rectangle is changing, so I'm going to kind of track what the lengths are. The length of this one's 3. The length of this one's 4. The length of this one is 5. And then for the width, I know the widths are changing, so let's write those down too. The width of this one's 2. The width of this one's 3. The width of this one's 4. Okay, so I got some numbers on it. Now my last step is to generalize how those numbers are related to the figure number. Okay, now a lot of kids, when they're looking for patterns, they try to see what the relationship is from one figure to the next. That's not what we're doing here. We're going to figure out how does the figure number relate to the numbers in that figure. Okay, I'll give you an example. Look at the width of this figure. It's 2. On figure 1, the width is 2. On figure 2, the width is 3. On figure 3, the width is 4. Notice the width is always just 1 bigger than the figure number every single time. So if I have figure X, the width is also going to be 1 bigger than the figure number. So on figure X, the width is going to be X plus 1, because it's 1 bigger than the figure number. And then similarly, let's look at the length here. The length of this on figure 1 is 3. On figure 2, the length is 4. On figure 3, the length is 5. Notice the length is always 2 bigger than the figure number. So on figure X, the length will be X plus 2. Okay? So now that we've kind of generalized this, we can easily write an equation for this. Let's let Y be the number of squares. Okay? And for a rectangle, the number of squares in a rectangle is pretty easy. You just do length times width. Okay? So for example, if the length and width are 4 and 5, 4 times 5 is 20. That's the number of squares that are here. On this figure, the length and width are x plus 1 and x plus 2. So if I want to know the number of squares here, I just do x plus 1 times x plus 2. There's my equation. Now, you can always just check to see if this actually works by picking one of these figure numbers and see if the equation gets you the exact same figure. So let's pick figure 2. Okay? For figure 2, I'm going to put 2 in for x. 2 plus 1 is 3. 2 plus 2 is 4. So this is saying the number of squares is equal to 3 times 4. And if you look over here, 3, 4. 3 times 4 is 12. That would give me the number of squares there. It matches up. Okay? Now that was a fairly straightforward one. Let's do a slightly more difficult one. All right? Pattern 2. Figure 1, figure 2, figure 3. We've got L's here. Okay? Now when I see this pattern, I kind of see a rectangle with a square on top. Rectangle, square on top. Rectangle, square on top. Okay, so I know for figure X, it's just going to be a big rectangle with a square on top. Figure X. Okay, now let's put some numbers on this. Now I know that square on top is always going to be 1, so that's pretty easy. It's the rectangle that seems to be changing. Notice the width goes from 1 to 2 to 3. So notice, the length of this goes from 4 to 5 to 6. Okay, so good. I've got some numbers there. Now let's relate the length and width to the figure number. For figure 1, the width is 1. For figure 2, the width is 2. For figure 3, the width is 3. Okay, so you can kind of see it, right? The width is always the same as the figure number. So for figure X, the width is going to be X. All right, now let's do the length. The length is 4 on figure 1. It's 5 on figure 2. It's 6 on figure 3. Notice, the length is always 3 bigger than the figure number every single time. So on figure X, the length is going to be X plus 3 because it's 3 bigger. All right, so we now have enough information to write our equation. So let's do this. The number of squares is equal to the area of the big rectangle, so length times width, x times x plus 3, plus that one additional square on top. There we go. There's my equation. And again, if you're not sure, let's check it with one of the figures. Let's try figure 3 this time. Okay? This says if I put 3 in for x, I'll have 3 times 6 plus 1. 3 times 6 plus 1. Let's look at this thing. To find the number of squares, I'd do 3 times 6 and then add the 1. There you go. It's exactly it. And notice, to check my answer, I didn't even have to actually calculate the number of squares. I just look at how would I calculate the squares based on the figure. All right. One last one, and this one's a little bit harder. So for pattern 3, notice we've kind of got a Z shape. There's a lot of different ways you could visualize this pattern, okay? Some kids visualize it as a square in the middle with 2 kind of lines of squares on top and bottom. I'm going to visualize it a little differently. I like to visualize it as a rectangle with 2 squares on the end. Rectangle, square, square. Big rectangle, square, square. Rectangle, square, square. Now the thing about this pattern is, no matter how you visualize the pattern, if it's an accurate way to visualize the pattern, your equation's still going to work either way. But let's set this up this way. So for figure X, I'm going to have a big rectangle and then a square and a square. So figure X. Okay, so let's do this now. So we've kind of generalized what the pattern is. Now let's put some numbers to it. Every single time, we know these single squares are just going to be 1 because these are not changing. So this is going to be 1 and this is going to be 1 even on figure X. Okay? But what is changing is the length and width of that rectangle in the middle. So this rectangle is a 1 by 3. This one's a 2 by 4. This one's a 3 by 5. This one's a 4 by 6. Okay. So now let's see if the relationship between those numbers and the figure number. Notice for figure 1, the width is 1. Figure 2, the width is 2. Figure 3, the width is 3. I think you already see it. The width of the rectangle is the figure number. So for figure X, the width is X. Okay, let's do the height now. For figure 1, the height is 3. Figure 2, the height is 4. Figure 3, the height is 5. Figure 4, the height is 6. Notice, every single time, the height is 2 bigger than the figure number. So if my figure is figure X, this height's going to be X plus 2. All right, we now have enough information to write an equation for the number of squares here. So the number of squares is going to be the number of squares in this rectangle, so length times width, x times x plus 2. Plus, we have to add on those additional 2 extra squares. There's your equation. And again, if you want to check it to make sure it works, you can pick any of these figures and try it. Let's try figure 4. If x is 4, this will be 4 times 6, because 4 plus 2. 4 times 6 plus 2. Let's look at this figure. 4 by 6 is the rectangle, plus 2 is the additional squares. That works out. Okay? So that's how I would go about writing equations for square patterns. Hopefully you found that helpful. If you did, please hit that like button. Also subscribe because it really helps us out. But with that being said, good luck on your math, and I will see you next time.